My name is Heaven, and today's episode will be featuring Mia Diamond and Avia Keene, and we will be explaining the different types of waves. The first type of waves I'll be explaining are mechanical waves. Mechanical waves are a disturbance that travels through a material called the medium and transfers energy from one place to another. A mechanical wave must have a medium to travel through. Let's go over to Mia to explain the term medium.
I'm Mia Diamond. I will be explaining a medium. A medium is something that is average or the middle of a range. This is an example of a medium. It's the pink line, if you can't see it. Now Via will be going over transverse waves.
A transverse wave is a wave that causes the medium to move perpendicular to the direction of the energy. If the wave is moving to the left, then the medium will be going up and down. In my example, I will be dropping a rock into water, and you will see how the waves, I'll just show you this. The waves go out, but then the water stays going up and down. Now we're going to go back to Mia to explain longitudinal waves.
Now I'll be explaining longitudinal wave. A longitudinal wave is a wave that causes the medium to move parallel to the direction of the energy. An example of this is if an arrow is going right, then the medium will be going out like this. Now Heaven and Avia will explain crest and throat.
There are two parts of a media line. The first part is the crest, which is the highest point on the line.
The second part of a median line is the lowest part, which is called the trough.
Now we're handing it back to Mia to explain compressions.
I'll be explaining compression. A compression is a part of the wave that is close together. Now I'll be giving it to Heaven to explain a rarefaction.
A rarefaction is part of the wave that is farther apart. Rarefactions are the opposite of compressions, but it also depends on the wavelength. Avia will now explain what a wavelength is.
The wavelength is the distance from one same point to the next. For example, for a transverse wave, it goes from the top of the first crest to the next. And with a longitudinal wave, it goes from the top end of the first compression to the end of the next compression. Now Mia will explain amplitude.
Have you ever wondered what an amplitude is? An amplitude is how high up the wave goes. So it's from the top and the bottom of the wave and how high it goes. Now I'll be explaining the Doppler effect. I'll be explaining the Doppler effect. So the Doppler effect is the charge and frequencies of a wave. As the sound source and observed move related to each other. An example is when something is coming towards you, it has a high pitch, and when something is behind you, it has a low pitch. Here is the demo. Now Heaven will explain wave reflections.
A wave reflection is when a wave hits something that cannot go through, and instead of going through, it bounces right off. This is similar to how a light reflects off a mirror. Now I'm passing it on to Avia to explain wave refractions.
A wave refraction is when a wave actually enters a new or different medium. But when the wave enters the new medium, it changes direction due to the change in speed. In reality, the wave is just in a different angle because it either slows down or speeds up. Fun fact, rainbows are caused by wave refractions. For a better understanding, you can take a cup of clear water and place a pencil in it, and you will see how the direction changes of the pencil. That's it. Now I will be explaining destructive interference. This is when the crest of one wave meets the trough of another. When they meet, it makes them smaller and makes it into one small wave. And then they just keep going, so they keep going and they flip sides.
Have you ever wondered how a microwave cooks food but not the dish? When you put food into a microwave, the microwave uses electromagnetic waves to cook the food. The food absorbs heat while the dish doesn't. Although the food can make the dish hot because the molecules like water, sugar, and fat in the food absorbs heat.
Okay, now as a group, we'll be explaining electromagnetic waves. These are energy waves that do not need a medium to go through. They can travel through a vacuum. A vacuum is a space devoid of all matter.
Ultraviolet radiation is visible energy from the sun. For example, when you go outside and you're in the sun, your skin absorbs the ultraviolet radiation.
It is important to know that when these waves hit something, the energy that they carry is generally transformed into heat energy in that object.